Hey, Mr. Estrada here, and our learning target for this video says I can sketch the locus of points equidistant from two intersecting lines. Okay, so here we are, Locus Theorem 5. This is our 5th video in our Locus series, and I'm just going to call this Locus Theorem 5, intersecting lines, because in this theorem you are given two intersecting lines and you will be asked to sketch the locus of points equidistant from the two intersecting lines. So here's what it says. The locus of points equidistant from two intersecting lines, L1 and L2, is a pair of bisectors that bisect the angles formed by L1 and L2. So here we have line L1 and here we have line L2. And the locus of points equidistant from these two lines are the angle bisectors that bisect the angles. So here is one of them. Let me just adjust that a bit. So that's one of the angle bisectors. You see how it's just cutting right through the middle of these two angles here, and you will have another angle bisector here. Is that straight? Let's see. Okay, there it is. So there you have it. So that's what the locus of points equidistant from two intersecting lines looks like, these dotted lines that you see here. All right, so that's the theorem in a nutshell. Let's apply it in two examples. It says sketch the locus of points equidistant from the x-axis and the y-axis. So we just saw that the locus of points equidistant from two intersecting lines, and keep in mind that the x and the y-axis are intersecting lines. So that's important to note. And we are asked to sketch the locus of points equidistant from the two intersecting lines, in this case the x and the y-axis. Well, that will be the angle bisectors. So it has to be perfectly cutting right through the middle. So it will be a line going through the origin with a slope of 1/1, and that will guarantee that it's cutting right through the middle of the angles formed by the x and the y-axis. And then we need another one going this way. And we are done. Right? So it's just basically two lines going through the origin with a slope of 1, and then the other line has a slope of -1. So we could say the equation of this line over here is y equals x. If you recall, the equation of a line is y equals mx plus b. So you know, obviously it's going to be y equals 1x plus 0 since it's going through the origin, but we can just simplify it to y equals x. And then the equation of this line will be y equals -x. So these are the equations that represent the locus. So the locus is the dotted lines. Let's try another example. It says sketch the locus of points equidistant from the line x equals 1. So let's go ahead and plot that line. So we got the line x equals 1, looks like this. And we also have the line y equals 2, and that will look like this, y equals 2. And let me just go ahead and label these. So here's the line y equals 2, and here is the line x equals 1. So we have to sketch the angle bisectors. So let's go ahead and do that. So it's got to go through right through this point, the locus, and with a slope of 1/1. So I can just go up 1 over 1, up 1 over 1. And you know, going by that slope, what that does is it guarantees that you cut evenly right through the middle, so that you'll be equidistant from the given intersecting lines. So there we have it. There's one of the loci, and let's see if I could just do the other one. Like, I just do it from here, and I guess then I can just extend the line. So it's got to go down 1, over 1, and make sure I'm following the slope. Yes, I am. So that's what the locus looks like. I mean, you know, if you want to make it look prettier, I suppose that you can make the two lines of the same length. So let me just extend this a little bit more. That's not really necessary. It's just for you know, cosmetics, or to make it aesthetically pleasing, I suppose. So those are your two dotted lines that represent the locus of points equidistant from the given lines. So what would be the equations that represent the locus? Let's start with this line over here. So remember, the equation of a line is y equals mx plus b. So of course the slope is 1, so it'll be y equals 1x. Now the b is the y-intercept, and in this case it's 1, so it'll be y equals 1x plus 1. That's the equation of this line. What would be the equation of the negative line? So of course, let me do the other one in a different color. This line will have a slope of -1 because it's got a negative slope. And the y-intercept is 3, so it'll be y equals -1x plus 3. All right, so you know, that's a nice little tutorial with the Locus Theorem 5, equidistant from two intersecting lines. So just keep in mind that equidistant from two intersecting lines, the locus is the angle bisectors that you know, that bisect the angles formed by the intersecting lines. So I hope this helps. Take care.